The next example will have us practice a redox titration. A sample of iron ore is dissolved in acid, an acid solution, and the iron is converted from a +3 to a +2. Friends, I need to adjust that in our note pack. Iron will start in iron ore as a +2, and it will go to a +3. We have to make that adjustment so our redox will actually balance. We then titrate 47.2 mils of a 0.0224 molar permanganate solution. Write the balanced redox reaction. So a practice looking at a redox. One of those, write the half reactions and combine back together. Let's do that together, please. Iron begins, oops, my pencil broke. Iron begins as a +2 and goes to a +3. We have to make that correction or we'll end up with electrons on both sides. To electrically balance this, we simply take, if a +2 goes to a +3, that's 1 electron to bring it back down to a +2 for both sides. There's the first half reaction. We have the permanganate, MnO4, that will go to a manganese +2 is the second half reaction. We will then add 4 waters to balance the oxygens, coming back to add 8 positive hydrogens to balance the H's, 8 H's, 8 H's, 1 Mn, 4 O's. On this side, we have a total of a +2. On this side, we're at a +7. So to the more positive side, I will add 5 electrons. Leo must equal Ger, so I can see that I'll distribute a 5 through the first half reaction and distribute a 1 through the second half reaction, and we'll simply add those back together and simplify. First half reaction shows 5 irons at a +2 from the top half, 5 electrons, 8 hydrogen ions, and an MnO4 -1. The combined reaction on the left side. The right side shows 5 iron +3s and 5 electrons from the first top half reaction. And on the bottom, we'll have an Mn +2 and 4 waters. The only thing I can see to simplify are the electrons, and here is my reaction for this redox. I knew it was an acid. I don't need to do the combining of the base ion. It's an acid solution. Our stoichiometric ratio, 5 iron +2s with 8 hydrogen ions plus a permanganate at a -1, produces 5 iron Roman numeral 3s, manganese +2, and 4 waters. We needed that part of the equation before I even cared about the numbers. We wrote a balanced redox reaction using the half reaction method. How many moles of MnO4 are added to this solution? That's coming back up here to the numbers provided in the problem. We were given volume and we were given the molarity. We're asked to pull out the number of moles. So, the very definition of molarity says there's 0.02240 moles of permanganate, MnO4 -1, per liter of solution, moles per liter, the definition of molarity. I'll multiply that by the volume, 0.0472 liters of solution. I'll just set that over a 1. Molarity times liter will find the number of moles of our permanganate. And let's hit that together. .02240 moles per liter times 0.04720, that's our liters, finds a mole number 0.001 0, and I'll round here, 6. There's our moles of our permanganate. How many moles of iron 2 were in the sample? This is just looking at a ratio. From our balanced equation, I can see that for every 1 mole of permanganate, 1 mole, we have 5 moles of iron carrying a +2. So our given 0.00106 moles of permanganate times the heart of our problem, our want over given ratio. We want to know iron, its coefficient is a 5.